Hello students, in this session we are going to study the simply supported beam with point load. The point load is at center and we want to find out the maximum deflection and maximum slope for this beam using moment area method. MAM means moment area method, right? So we know that the elastic curve for this type of beam is like this, and the maximum deflection will be at the center. Maximum deflection will be at the center here, y max, and maximum slope will be at the supports. Suppose here this is theta a or theta max, right? So maximum deflection is here and maximum slope is here, right? And we want to find out maximum deflection and maximum slope, both things we want to find out, right? Using Mohr's theorem. According to Mohr's first theorem, we have to choose the slopes, right? So one of the slope is theta max itself, one of the slope is theta a. So theta a, we have chosen theta a or theta max, right? Second slope we have to choose where the slope is 0, right? So that the difference of two slopes may be give the maximum slope, right? So the point on the elastic curve where the slope is 0. So this point where the beam is changing sign from where there is a minima, right? So you can see here the slope of this point theta c is 0. Slope of this point is 0, right? So theta c is 0, right? The slope of the intermediate point, because the curve is changing from lower to first it is increasing in negative direction and then decreasing, right? So this is theta c is 0, right? So we have chosen these 2 points a and c, right? So what is the theorem? That the difference of these 2 points theta a minus theta c will be equal to area of the bending moment diagram, area of the bending moment diagram between a and c. So we have to draw the bending moment diagram also. First of all, we will define this, that area of bending moment diagram between a and c divided by ei. So area of the bending moment diagram divided by ei, and theta c is 0, so we will get theta max as a by ei, right? A by ei. So we have chosen points a and c, right? So this area is the area of bending moment diagram between a and c, because c point is the slope of 0 slope and a point is the slope of maximum slope, right? The point of maximum slope, right? So now what we have to do is we have to draw the bending moment diagram. For that, first we have to take the section. Let us take the section here, any section here, x, at a distance x from the this a point, right? And what are the reactions? You know that if the load is applied is W, then the reaction at this point is W by 2, and reaction at B point is also W by 2. So RA and RB will be equal to W by 2, right? So MX will be equal to here I can write here the MX will be equal to the reaction, the moment of all the forces to the left of the section. So there is only one force, W by 2, so W by 2 multiplied by X. So W by 2 multiplied by X, this is MX, and this is valid between A to C, right? This is valid between A to C, and this is positive, right? So another is we have to take the section here, say here, right? And this is valid between A to C, because there is another load, so we have to take one more section here, and we can take to the right of the section. Suppose this we can take here. So another say this is MX, this is MX1. So MX1 will be equal to, moment of this W by 2 about X1, right? So moment of W by 2 about X1, again W by 2X, and this is valid between B to C. So for full length A to C and B to C, we have obtained the bending moment, right? And what are the extreme points where the bending moment we can find out? A and C and B and C, right? So MA, according to this, MA will be equal to 0 because x is 0, because x is, we are taking here. So based on this we can find out MA to be 0 and MC will be equal to WL by 2, because at C the length is L by 2. So this is WL by 4. WL by 4. This is WL by 4, right? So this data is obtained from this part, right? And from this part we can find out MB equal to 0 because x is 0 at B point, and MC is again WL by 4. So this data is obtained from this equation, right? Now we can draw the bending moment diagram here. So drawing the bending moment diagram, we can draw now the bending moment diagram. Suppose this is our reference line, the beam, right? And we have to draw the bending moment A to B, and the intermediate point is this C. From 0 to WL by 4, 0 to WL by 4, and then from B this is 0 to WL by 4, and linear variation because x curve is there. This is linear variation, right? So this length is WL by 4, right? From 0 to C point, this is C point, WL by 4, and then from 0 to WL4. So total is, this is the bending moment diagram, right? So this is the bending moment diagram for seamless programming. I am erasing this part because it is not needed. We already know how to draw the bending moment diagram in shear force and bending moment diagram chapter. So this is the WL by 4. Now we want to find out theta max. So theta max will be equal to area. How to find out the area? So finding the area between A and C, So this is A point, this is C point, and this is the area. This area we have to find out. This area, right? So what is this area? This area is half into base. This is our base, which is distance L by 2, into height, which is L and WL by 4. So area of this part between A and C will be equal to half multiplied by base is L by 2, multiplied by height, WL by 4. So this will be equal to WL square by 16, WL square by 16, right? So this is the area, WL square by 16, right? So put here WL square by 16, you will get the theta max. So theta max will be area WL square by 16 EI. So this is the theta max, maximum slope, because area is given by half into base into height, right? Because area between A and C is given by half multiplied by base multiplied by height, which is WL by 4. So this is WL square by 16, right? So using this area here, we have found out the theta max. Now we want to find out the Y max. How to find out Y max, right? So this value I have written here, so I can rub it, right? So this is the area between A and C. So this area we have utilized in this equation of theta max, right? Now finding the Y. For finding the Y, we have to choose 2 points and we have to take a reference line. So let us take reference line on this support only. So here we are taking the reference line, this, and one of the curve should be parallel to this line and another should be tangent to this. The tangent should pass through this point and another should be this point, so that Y max may be obtained, right? So for Y max can be obtained by taking the tangent of this C and this is and crossing this point, right? So this is the, I'm rubbing this. So this is our, to obtain Y max, this we can take the tangent of C, which is intersecting at this point. So this is tan C, the tangent of C, tan C, and tangent of A should cross from this point, so that we can, one of the tangent should cross this point, so that we can obtain a y max. So tangent of A is crossing from this point, so this is the tangent of A, tangent of A, right? So one of the tangent should pass through this point, and another point, tangent of A is passing through this point, and then this length will give the, when two tangents will be crossing this point, so this length will be the y max, right? This is the y max, right? Y max, because two tangents are crossing at A and at this point, right? So tangent of A and tangent of C we are taking, tangent of A and tangent of C we are taking here, right? So we have chosen point A and C, tangent of C. Now the area, the moment of area. So that what is the Morse theorem? That y max will be obtained. Y max may be obtained by taking the tangent, that moment of that area, moment of area between A and C, that is x bar is the moment, and divided by EI, right? So this A is the area between A and C, x bar is the moment of this area about this reference line, and this is our reference line. This is the reference line, right? So this A is basically reference line. So what is the total area of this A between A and C? We have already obtained area, this WL square by 16, and this WL square by 16 will be, this WL square by 16 will be acting at this point. Suppose this is WL square by 16, and the moment of this area is this distance which is x bar. And what is x bar? Half into base into height. So this is 2/3 of the total distance, 2/3 of the total distance, right? So this is 2/3 of L by 2. So this is 2/3. So x bar is basically 2/3 of L by 2. So this is L by 3. L by 3. So x bar is basically L by 3, right? So this is the this is center of gravity, and this distance is the distance of center of gravity from the reference line. So center of gravity is lying at a distance of 2/3 from the vertex, right, of a triangle, because this is a triangle. So 2/3 from the vertex, 2/3 of the this distance AC, and this distance is L by 2. So 2/3 of L by 2 is L by 3. So this is x bar is basically L by 3, right? So x bar is L by 3. We know now. Area is WL square by 16. So we can take the moment of area about this reference line as area multiplied by this distance, right? So Ax bar will be given by area WL square by 16 multiplied by x bar, which is L by 3. So this will come out to be 1 by 48. 1 by 48. So WL cube by 48, right? Now we can put here, so we can get y max as, y max can be obtained as Ax bar, moment of area, WL cube by 48 EI. So this is the answer to this question, 48 EI, right? So how we have obtained now? We have obtained the difference of slope using Morse first theorem. Difference of slope is this, area of bending moment diagram divided by EI. So we have chosen A and C point because the slope at C point is 0 and slope at 8 point is maximum. So we can, by this we can got the maximum slope, right? Another we have obtained the 2 points, so a reference line, so that the tangent of 2 points should lie in such a way that we can got the maximum distance. So which 2 points, the slope of which 2 points is getting from passing through these A and C. So slope of A is passing through this point and slope of C is passing through this point. So this distance, because these two slopes are crossing this line, vertical line, so this distance will give the maximum distance, y max. So y max can be obtained by taking the moment of this area. This area is A and moment of this area is x bar. The distance of this CG, center of gravity or centroid of this area about this reference line. So this is AG, right? So this is L by 3, 2/3 of total distance, right, which is L by 2. L by 2 is the total distance between A and C. So this is L by 3. So Ax bar will be equal to area multiplied by the distance of centroid from the reference line, this we have got this thing, and y max will be WL cube by 48 EI. So this is how we can obtain the maximum slope and maximum deflection for a simply supported beam loaded with a point load at the center.